Hey everybody, this is Mr. Munson, and we are in Unit 10, Transformations. This is concept number 2, Part 3, Rotations. And so what we're going to be looking at here in this video is rotating in the coordinate plane and seeing how that works. All right, let's go ahead and get started. All right, let's take a look and just make sure we understand the idea of what rotation means. So here's some circle with a center of H, and here's K. Okay, so what I'm going to do is I'm going to take K and I'm going to rotate it around the circle, something like this, right? That's rotating around the circle. And I would think that would be about 180 degrees. Now let's just take a look at something real quick. Let's put it back up here. I'm going to take this K prime, put it there, and I'm going to rotate it around so we can keep track of where K was and K prime. So I'm just going around, and I think this is about 180 degrees. That's not too bad. Let's go ahead and move this back right there. That's about 180 degrees. Now this is what I know. In the basic sense, I have angles that can have a vertex here at the center of the circle, right? Well, there is an angle that has a vertex at the center circle. It has a ray that goes out here and another ray that goes this way. And that angle is 180 degrees. It's an angle that's been opened up 180 degrees. So, because it's a central angle, the vertex is at the center, we know that this is 180 degrees of arc. Now I'm hopeful, I'm hopeful that if you understand K prime going 180 degrees as I rotate it this way, would have ended up in the exact same location if I had gone around over here from that other direction. Okay, now let's do 90 degrees. So let's rotate it 90 degrees and I come down here, and that looks about right. Now, according to that, if I draw a right angle, it should go right through that point. Let's see how I did. Hey, pretty close. Okay, so that was 90 degrees of rotation, but I gotta tell you, that's an error. I went in the wrong direction. And through today's lesson, you'll find out why that was in the wrong direction for 90 degrees. I really should have put it over here. There's a couple of ways that we're going to talk about how to tell the person who's drawing which way to go. Let's go ahead and continue. So as I was saying, 90 degrees, that's a positive 90 degrees. Now, if I wanted you to go in a negative 90 degrees direction, I should have said negative 90 degrees. So I think if you remember right, I said, I went around the clockwise direction, and I said that did not equal a positive degree of rotation. Here's the reason why. In the world of math, we know that that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if you take a look, rotating in this direction is a positive rotation because that would go 1, 2, 3, 4. It's going up. If I rotate the other direction, it'd be like 4, 3, 2, 1, descending. Okay? So that's the reason why it's positive direction. So in other words, counterclockwise is positive, clockwise is negative. That's probably different than what you expected, but remember, we're working in the world of math, not in the world of time. So that's why it's that way. So here's a point called 3, 2, and I want to rotate that 90 degrees. So as this rotates around, it's going to end up someplace over here. I said 90 degrees, so that means it's going to be a positive rotation, which is counterclockwise. I wonder where it would be. That would definitely be more than 90 degrees. So let's just draw ourselves something to give us a time or a frame of reference here. So there's a 90-degree angle, and let's rotate this 90 degrees. So we'll rotate it right over to there, and sure enough, that's the rotation, okay? So that point right there is known as -2, 3. Now I want you to look at that and realize, wow, it's not some weird numbers, not like all of a sudden 5, 6, or 10, 12, or something like that. It's the same numbers, just in a different location. And the signs have changed. Now, what we're going to find out is that there's a bunch of rules that we could use for flipping every 90 degrees. You do this. If you go left, you do a certain rule. If you go right, it's another rule. If you go 270 degrees to the left, it's a certain rule. And if you go to the right, it's another, 270 degrees, positive, negative, all this. It's very confusing. So what I'm going to do is I'm going to teach you a method called the flip and force method. This is trademark and it's my own, so I'm very proud of it. But I think it works. Most students find this a lot easier than trying to remember where these points will go or even kind of visualizing it. So this is how it's going to go. First of all, you flip the coordinates until you land in the quadrant you want. That's every 90 degrees, you flip the coordinates. And so what ends up happening, we'll do a couple of these to make sure you understand, as you move from quadrant to quadrant, the numbers will go from, let's say, 3, 2 to 2, 3, and then 3, 2, and then 2, 3, and it'll just flip back and forth until you end up in the quadrant you want to be in. Once you land in the quadrant, then you force the signs, the negatives, whatever, to match the quadrant that you live in, right? So as this rotated here, it was at 3, 2. As soon as I got over here, I would say 2, 3, and I would write it down real quickly so I don't forget the order. I flip it, and then I'd check and see if the signs work. Well, I know in that quadrant, the x's are actually negative. So I'll put a negative in front of the x's, and the y's are positive, so I'll leave that alone. And that's why it ends up being negative 2, 3. Okay, let's take a look at this one. This is point B, and it's at negative 4, negative 1. Now we're going to rotate it negative 270 degrees. Well, negative 270 degrees is in this direction. I want to encourage you, whenever you see how many degrees you're rotating, to write that in its place. Now, I could also tell you to go clockwise, and then you just know it goes in the direction that a clock would run, and it would be in that direction. If it was a positive rotation I wanted to tell you, then it would be counterclockwise. So there's several different ways I could tell you in which direction to go in. So the first step is to realize which direction we're going to be rotating in, and then what quadrant am I going to finally land in. Okay, so I'm in quadrant 3 here, and I'm rotating negative 270. The first 90 is going to get me here, the next 90 is going to get me over here, and the last of the 90s, 270 degrees, is going to get me into quadrant 3. So this is where I'm going to land. Now my hands, when I'm doing this, look just like this. I have my palm down, I stick it to represent the two numbers. And then what will happen is I'll move my hand up into the next quadrant, and I'll replace it with this hand. Representing in my eyes and in my head, I've flipped the coordinates. So then when I move this over here, I'm going to move it over here, and then as soon as I get here, I will replace it with my hand looking this way. And then when I move it down here, I'll look like that. Okay? Let's take a look and see how this actually works. So here we are. I'm going to start here, and I'm going to say the numbers out loud, and then as I move up into the next quadrant, I'll flip them and say them out loud again. This will help me keep track, okay? Now here's something that's important. I don't need to say negative 4, negative 1, and then come up here and go negative 1, negative 4. The negatives don't really matter because when I land in the quadrant, all the negatives, wherever they are going to disappear. So I really just need to replace that with this idea. So I just say the numbers, 4, 1. So let's begin. We'll say 4, 1, and then when I reach up here, I just replace my hand with this one, and I say 1, 4. Now I don't usually write down what it is. So again, I just use the flipping of my hand to make a visual impression to myself I'm flipping the coordinates. So then I'll take that, I'll say, let me restart here, I'll go 4, 1, and when I get up here, I flip my hand and go 1, 4. So then I move my hand over here, and I flip it, and I flip it like this, and I say 4, 1. Now I'm going to flip it one more time to get down to the quadrant. So as I move my hand down here, I'll replace it with this hand and say 1, 4. And I'll write that down very quickly so I don't forget what order it is I've landed in. Okay? So once I'm here, that's when I'm going to force. So I flip the coordinates every 90, and then I force the signs on the numbers for the quadrant they live in. Now I know in this the x's are positive and the y's are negative. So let's put a negative on the y, and that point right there represents one, 1, negative 4, That 1, -4 represents the point that's over here that's rotated all the way over here to 1, -4. And so that's 90 degrees rotation, for that, or 270 degrees of rotation for that thing. Okay? All right, now don't go any further. Put me on pause if you don't quite understand that, and go back and watch that scenario one more time, okay? Now, keep in mind that I'm not writing these things down. I'm just simply saying them out loud when I get there. That saves me the writing time, okay? Okay, now it's your turn. If you're on this page right now, if you're watching this part of the video, then you understand the flip and force. If you don't, you need to go back and watch that again. This is the one you practice to try to figure out. So if you were to watch this and come in and say, I didn't get it, you should have never made it to this part of the video. Okay? So put me on pause and see if you can do this one and find out where your point would be with a positive rotation of 270, this point 3, -2. Come back and check your work. Okay, I got -2, 3. As you can see, I got over here. I quickly wrote down the order when I got there, and then I forced the signs to work, okay? I got it wrong. My x's are negative there as well as my y's. There we go. All right, cool. So just to remind ourselves, we're going to go, we say to, we go ahead and drop the negatives here. We just call it 3, 2, 2, 3, 3, 2, 2, 3. And there I have it. Write it down quickly and put your negatives where they belong. All right. Now I could certainly ask you to rotate figures like this a certain amount. And what you would want to do is just see it as simply the 3 different problems, right? 3 different vertices, and you just rotate each one at a time. So if I told you to rotate at 90 degrees, you'd go to the left 90 and so on. Okay? Now that's it. Now, be sure to ask me how to check your answer using another piece of paper over your drawing to check to see if your rotation is correct. And that'll make it so that you get it 100% correctly done. All right, that's it. Let's go ahead and practice.